Welcome to today's ABC UTC Research Seminar. The presentations in this seminar highlights research work at the ABC UTC's partner universities. Each seminar consists of a 40-minute presentation followed by a 15-minute question and answer session. My name is Mary Lou Rawls-Newman, Director of Technology Transfer at the ABC UTC. I'll be moderating today's seminar. I'll be assisted by Paul Lyles, former Georgia State Bridge engineer, and Jugesh Kapoor with WSP USA and formerly State Bridge Engineer at WSDOT, both members of the ABC UTC Advisory Committee, who will be moderating the Q&A session. Ali Javed, Ph.D. student at FIU, will be managing the web room. We're pleased to welcome participants at approximately 350 registered sites for today's seminar. The seminar today features the ABC UTC research project on alternative technical concepts for contract delivery methods in ABC, conducted at Florida International University. We'd like to thank Armin Mehrabi, co-director and director of research at the ABC UTC, for coordinating today's featured research project. We're pleased to introduce our presenters, Mohamed ElZomor, principal investigator, and Piyush Pradhananga, Ph.D. student. We'll now begin our presentation. Mohamed?
Good afternoon, everyone. And first of all, I would like to thank you for your time for joining our seminar today. Again, our seminar's title is Alternative Technical Concept for Contract Delivery Method in Accelerated Bridge Construction. And my name is Mohamed ElZomor, and I'm the PI for this project. Briefly, I would like to introduce what is the topic about, and then introduce the speaker. First of all, I'm sure that all of us understand what ABC is about. There are clear benefits to early contractor involvement within ABC projects. So how can we get a contractor to be involved in a contract as early as possible? Alternative technical concepts, ATCs, which Piyush, the presenter, is going to refer to throughout the whole presentation. It is alternative technical concepts, which is another method for an early contractor involvement, allowing contractors to propose modifications to contract requirements before the bidding or the proposal process. Therefore, this study will also be geared towards addressing these issues in ABC methodology in general and how to embrace the benefits of ATC in our projects. Again, it is a privilege for me to introduce one of our great scholars, a Ph.D. candidate at Florida International University, Piyush Pradhananga. He is a Ph.D. student at Florida International University, School of Construction, Infrastructure and Sustainability, College of Engineering and Computing. Again, I'll let the floor now for Piyush to present the presentation for us. Please, Piyush.
Thank you. Good afternoon, everyone. I'm Piyush Pradhananga. I'm a PhD candidate in civil engineering at Florida International University. I would like to thank everyone, today's audience, for taking time to join today's research seminar. I would also like to thank ABC UTC for providing me this opportunity to present our recently completed research project on alternative technical concepts for contract delivery methods in accelerated bridge construction. The outline of today's presentations. First, the presentation will focus on the motivation of this research project and why this research project may support improving the US infrastructure system. Secondly, the presentation will highlight a brief background and introduction to different concepts of accelerated bridge construction, as well as alternative technical concept, also known as ATCs. Then we will look at some of our research objectives. After that, the presentation will focus on results related to case studies, SWOT analysis, analytical hierarchical process, and decision-making framework. Additionally, we will also look at the practical application of this research project, and the presentation will end with a conclusion. Bridges provide crucial access between regions and cities, linking workers to jobs, goods to markets, and people to essential services. However, out of 600,000 bridges in the United States, approximately 42% of the bridges are more than 50 years or older and are either structurally deficient or approaching the end of their design life. Some states have definitely worked hard to address the problem and have shrunken the backlog of deficient bridges to some extent. However, approximately 46,000 bridges are still in poor condition and require immediate attention and investment. Structurally deficient bridges require significant maintenance, rehabilitation, or replacement. And as we all know, delaying these activities could have serious consequences for the public. Therefore, the motivation of this research is to support bridge stakeholders to not only accelerate, but also reduce the cost and integrate innovation while rehabilitating or replacing structurally deficient bridges. ABC is an off-site bridge construction technique or prefabrication of bridges in a controlled setting that provides higher durability properties than the traditional cast-in-place method. To this end, accelerated bridge construction has definitely revolutionized the construction industry through faster delivery of projects with reduced congestion and safe execution. However, the ABC method may not be appropriate for all bridge construction projects, and the adoption of the ABC method may require higher investment or may sometimes result in liquidated damages, as were observed in some of the case studies that we studied. For instance, in one of the case studies we reviewed during literature review, there were challenges in constructability faced during the adoption of ABC technique. The study highlighted that the contractor faced issues during bridge construction due to misalignment of longitudinal post-tensioning ducts caused by design errors during the prefabrication process. Consequently, there were delays in schedule, and the contractor adopted the conventional cast-in-place method to complete the construction process. Moreover, while integrating ABC within traditional project delivery methods such as design bid build, there is no collaboration between a designer or architect and general contractor during the design phase. This makes the process slower and increases the challenges in constructability of the bridge structure in the construction phase. An alternative technical concept is a potential solution for addressing this issue in ABC projects. Basically, ATC is a proposal made during the bidding or procurement process to gain competitive benefits in terms of modifying the project scope of work. An example of ATC integration in a bridge project could be changes to the vertical and horizontal alignments of a bridge or changes to the ramp configurations, among others. Many highway road projects have exploited the benefits of ATC, which includes early contractor involvement, reduction in overall cost and duration of the project, and integration of innovation, creativity, and best value to the owner. However, during our investigation, we found that very few ABC bridges have integrated ATC for contract delivery of ABC projects. In this figure, we can see that there is a separate guideline for ABC construction method and a separate guideline for alternative technical concepts for highway roads. However, to this end, there is no separate guideline or any decision-making framework for supporting ABC stakeholders to successfully adopt ATC during project delivery of ABC project. This slide will focus on differences in ATC submittal period in each project delivery method of a typical highway road project to give the audience an idea about how ATC submission works. As shown in this figure, in design bid build method, DOT requests bids on the completed baseline design, and contractors may submit their bids with ATCs. In this method, DOT implements a confidential process to review ATCs with contractors, and the lowest bidder wins the contract. On the other hand, in design build project delivery method, design builders conduct solicitation of design and construction proposals only after a request for proposals is issued on partially completed designs. And design builders may submit their proposals along with the implementation of ATC. Similar to the first method, DOT implements a confidential process to review ATCs with design builders, and based on the selection criteria in request for proposal, DOT selects the winning design builder. In comparison to the other two project delivery methods, the striking difference in CMGC ATC submittal period is how early the agency gets input as an ATC. This early input is possible because the competing contractors can be evaluated based on their potential to add innovative alternatives to the project before selecting the winning contractor. One of the most significant procedures for ATC integration is the conduction of one-on-one meetings to ensure confidentiality. Competitors are allowed to have confidential one-on-one meetings to determine potential ATCs and receive an indication response from the department for a given ATC. This slide shows the ATC response rules and regulation in Washington State DOT, which may or may not vary from other states. Overall, the most common response includes ATC is approved or ATC is not approved, and ATC is not approved but may be reconsidered for approval upon satisfaction, and sometimes the submission may not even qualify as an ATC. Based on a 2014 NCHRP study of state DOTs, 33 states either responded that they used ATCs or were known to have used an ATC in highway road projects, as you can see in this map. In the map, all the state DOTs with dark gray color indicated that they have used ATC in highway road projects, while state DOT with black color had no response, but the use of ATC has been identified in some of the case studies. All other states either didn't use any ATC or didn't respond to the survey conducted by the authors. It can be concluded from this map that the use of ATC in highway road project is relatively higher, and future ABC projects should also exploit the benefits of ATCs to replace thousands of bridges across the US that are structurally deficient. There were 4 main objectives of this research project when we started the research, which includes documenting recent case studies of ABC projects with and without alternative technical concepts, identifying strengths, weaknesses, opportunities, and threats or SWOT matrix of ATC integration in ABC projects, conducting analytical hierarchical analysis of critical factors impacting the integration of ATC in ABC project, and developing a flowchart that will help decision makers make an informed decision on the integration of ATC in future ABC projects. In this presentation, I'll be focusing more on the results of these objectives. We utilize a qualitative approach in this study by conducting interviews with key stakeholders involved in ABC projects, such as contractors, design build managers, FSWA professionals, and technical experts. The table here shows the summary of the case studies of ABC projects with and without ATCs to understand the benefit of integrating ATC in ABC projects. In this presentation, I'll be focusing more on those ABC projects that integrated ATC to understand the overall impact of the ATC process on the final cost, schedule, and performance of the project. Then I will summarize the strengths, weaknesses, opportunities, and threats of ATC integration in ABC project in comparison to those ABC projects that did not integrate ATCs. The first project that we studied was Hastings Bridge project in Minnesota. Minnesota DOT utilized the design build contract delivery method for the construction of ABC project with a total engineer's estimate of $220 million. There were some challenges in the construction of the new ABC bridge, such as complex foundation requirements, traffic control complexity, construction duration, impact on local businesses, and presence of temporary structures. The Minnesota DOT integrated an alternative technical concept to overcome these challenges, and it also significantly reduced the cost of the project to $120 million. There were limits on the number of ATC submittals that could be submitted, and these were presented in 2 stages. In the first stage, concepts were presented to provide contractor with a decision on whether to pursue the solution. In the second stage, the ATCs for the project were approved through a confidential one-on-one meeting after the assessment of 6 to 13 ATCs from competing design builders. Ultimately, the winning bidder integrated 8 of those ATCs in the project to incorporate innovative design solutions such as geosynthetic reinforced soil, integrated bridge system, and the use of SPMT in the bridge construction. Moreover, the design build team utilized a continuous settlement monitoring instrument and a column-supported embankment as ATCs for the project. As reported by one of the interviewees that shared these project details, one of the major challenges faced during the project was reducing the impact on traveling vehicles. The project team addressed the issue by moving the bridge through the water, as you can see in this diagram, and the entire process was completed within 48 hours, which significantly reduced impacts on the navigation channel as well as adjacent roadways. To this end, this is considered to be the largest bridge move in the US using SPMT technology. The second case study that we documented in the Lardo Bridge project, which aimed to replace an 83-year-old bridge in Idaho. The conventional construction bid was estimated to be $6.4 million with a construction schedule of 259 days. According to the interviewee, the project team integrated ATCs in the design build procurement process, which significantly reduced the cost to $3.6 million with total 194 days of construction duration. Additionally, the integration of ATCs in the ABC project also reduced the impact on traffic and overall construction schedule. In particular, the new bridge was constructed on the northern part of the existing structure, which was then slid into place using a lateral slide accelerated construction method. Since the new bridge was constructed adjacent to the old bridge, while the old bridge was still in operation, this method reduced the full closure of the bridge. The 2.5 million pounds bridge was then moved about 70 feet over the course of several hours on a sliding surface by utilizing Teflon slide pads and stainless steel anchored to the concrete shoes. The third and last bridge project that we investigated through interviews is Route 8 Bridgeport Bridge Construction project. This bridge was located in Connecticut, and it was originally constructed in 1970s with an average daily traffic of 88,000 vehicles per day. Due to the high traffic in the area, the bridge was estimated to have reached its end of service life. Connecticut DOT originally estimated to complete the bridge overhaul within 2 years. However, considering the volume of traffic being impacted by the construction, Connecticut DOT utilized accelerated bridge construction and design build contract delivery method with ATCs for addressing these issues. These methods reduced the total on-site work schedule to 28 days of bridge replacement with minimal impact on traveling vehicles. Moreover, the integration of ATCs through innovative bridge design solutions like the use of modern weathering steel beams reduced the amount of maintenance required over their anticipated 75-year lifespan. This study also developed a SWOT matrix based on literature, interviews, and case study reports available on ATC-based ABC projects. This SWOT matrix will help the stakeholders understand how we can take advantage of ATC's strength, address weaknesses, deter threats, and capitalize on opportunities created by the adoption of ATCs within future ABC projects. To begin with, we identified 7 strengths that ABC stakeholders can take advantage of through the integration of ATC. First is early contractor involvement. Early contractor involvement is a strength because it helps to improve design, cost estimation, planning, constructability, and risk management, among others. Secondly, ATCs reduce ABC project duration and cost by avoiding change orders as well as eliminating uncertainties within ABC projects. Another strength is that ATCs are transferable. If the state wants to use the ATC from one of the teams that were not selected, they may do so by paying the team a stipend that varies by dollar amount, typically around $12,000. Moreover, the use of ATC is only approved if the alteration in baseline design or the baseline criteria is equal to or better than the original design of the ABC project. And this is a strength because it ensures the best value for the owner. The last 3 strengths have also been discussed in the case studies, and these include applicability of ATCs to all project delivery methods, enhancement in constructability, and incorporation of innovative technologies. Besides these strengths, ATC integration also has a few weaknesses. One of the weaknesses of the ATC integration is contractor recuperation of design cost. What this means is that when ABC design responsibilities are on contractors doing the modification of baseline design, contractors are less likely to participate in the ATC process due to the cost risk of hiring a designer. As reported by one of the interviewees, most of the DOTs would not reimburse contractors for ATC design cost. This requirement forces contractors to consider a risk reward of pursuing ATCs. Some contractors may develop an ATC by investing significant time and cost, while other contractors may put very little to no design effort when proposing viable ATCs. As such, it is critical to address this weakness by including payment for contractor design cost when ATC processes utilize contractor designs. Another weakness of ATC integration is that the owner can limit the amount of ATC which can be submitted for an ABC project. This is because the agency might become overwhelmed with the evaluation of all the submitted ATCs, which can cause potential delays in the project award. Since imposing a limitation on the total number of ATCs may also limit the industry's ability to innovate and add value to the project. So we believe that this weakness can be addressed by increasing the number of ATC that can be submitted. Lastly, there may also be challenges in ATC integration if there is lack of experienced ATC reviewer, because an untrained reviewer may impose subjective criteria and provide inappropriate guidance. So there should be training for all ATC reviewers, confidentiality agreements, a well-defined approval chain, and avoidance of third-party reviewers to overcome such challenge. As reported by one of the interviewees, the integration of ATCs during project delivery of ABC project is a rigorous and tedious process. The positive impact of such a process is that it encourages the opportunity to integrate best value solutions and sustainable practices. In terms of threat, some of the innovative technologies used as ATCs may increase the cost of the project, which is a possibility. Additionally, direct and indirect costs are not considered in ATC approval, and there might be issues if cost data is not considered. Similarly, there might also be challenges in defining quality assurance and incorporation of additional fees as a threat. Although the criteria used for integration of ATC in ABC projects may vary based on the goals and requirement of different ABC projects, the identified criteria in this slide were obtained from literature, and it represents the common criteria that have been evaluated in most of the ABC projects. This includes legal and contractual issues, direct and indirect costs, environmental impacts, risk assessment and innovative approaches to project execution, project schedule or duration, construction impact, and public perception or customer service. This figure in the slide shows the graphical representation of the normalized weighted score of the identified criteria, and these were analyzed using analytical hierarchical process. As shown in the graph, direct and indirect costs, project schedule, risk assessment and innovative approaches, and construction impact are the four most important criteria that should be evaluated while integrating ATC. On the other hand, legal and contractual issues, customer service, and environmental assessment have been found to have a lower weighted score, indicating that they may not be as important for ATC integration as described in literature. So we replaced these criteria with some of the other criteria that were recommended by experienced ABC stakeholders who had extensive knowledge of ATC. This is a flowchart that we developed based on literature, case study reports, as well as feedback and experiences shared by ABC stakeholders who also had knowledge about ATCs. The main objective of this flowchart is to assist ABC stakeholders in the decision-making process in terms of whether ATC needs to be integrated for contract delivery of ABC projects. The first phase is the pre-project planning phase, which is the essential stage of a construction project that focuses on identification of the needs of the ABC projects in terms of the selection of experienced and skillful project team members, as well as resources required to meet the owner's requirements. Secondly, during this phase, the contractor is also responsible for defining the scope of ABC project, assessment of project risk, and identification of a suitable project delivery method to be used for the project. In general, the determination of a suitable project delivery method for a construction project like ABC is a complex decision, and it may largely depend on project aim, budget, project schedule, associated risks, the expertise of stakeholders, and opportunities. However, since ATC can be integrated in any of these three most commonly used project delivery methods, there are no issues if any of the three project delivery method is selected. The goal of second phase is the evaluation of ATCs that have been submitted by the bidders. The first step of evaluation is the generic evaluation of ATCs. This process involves commencing confidential meetings to evaluate clarity in technical information as well as limitations of ATCs. During generic evaluation, it is also extremely necessary to conduct clarification of solicitation documents in a very confidential manner. The second step is multi-criteria evaluation. Based on the results of the analytical hierarchical process and semi-structured interviews, different criteria were finalized. Some of the criteria, such as environmental impact, legal and contractual issues, and public perceptions, were replaced by other criteria recommended by the interviewee, since those criteria had lower values of normalized value score, like I mentioned before. The finalized criteria for evaluation include construction time, construction risk, construction impact, improvement to safety, and innovation. This evaluation process will help to ensure that the proposed modifications are equal to or better than the original requirement, which is one of the most significant criteria of integration of ATC. When ATCs are evaluated for equal or better than the standard project requirements, direct and indirect costs are generally not considered. There may be issues if cost data is not considered, and the approval of ATC is based only on the technical evaluation. Also, there will be no expectation of specific cost savings, as ATC will be considered as the contractor's bid price. Since the primary goal of ATC integration in ABC project is reducing direct and indirect cost, it has been considered as a most essential criteria in this decision-making framework. Finally, if all of these conditions are satisfactory, the final determination of ATC approval and contract award can be issued by the respective DOT. Since integration of ATC has more advantages than disadvantages, we definitely want to encourage stakeholders to implement these lessons learned from our research project. In this slide, I'll be mentioning a few selected recommendations. First, ABC projects that integrate ATCs under any project delivery method should maintain the confidentiality of the proposal such that it allows the competing contractors to build a competitive edge with their ATCs. Consequently, this will promote innovation opportunities, improve level of constructability, and optimization of costs in ABC projects, which would consequently provide best value for the owner. Secondly, ATCs, when integrated with ABC projects, should revise the design that complies with the contractor's means, methods, and equipment. Such revisions would significantly reduce delays and potential conflicts in the design and construction of ABC projects. Additionally, by understanding the nature of project delivery system, by integration of ATCs, future ABC projects can improve management practices for ensuring effective project delivery and success of the ABC projects. And finally, to this end, many stakeholders in ABC industry are either unaware or reluctant to adopt ATCs due to uncertainty of the impact on project's cost, schedule, performance, and associated risks. We believe that this research project will help to increase awareness and encourage stakeholders to exploit the benefits of ATC in future ABC projects. To put it briefly, with the growing concern for more flexibility to adopt innovative solutions that will help to reduce risk of costly change orders in offsite construction projects like ABC, the integration of ATC in contract delivery is somewhat critical to maintain, replace, rehabilitate the structurally deficient bridges across our nation. However, despite the advantages of integrating ATC, a minimal number of infrastructure projects like ABC has integrated and thoroughly investigated such approaches. Therefore, our study investigated case study projects as well as developed a decision-making framework and SWOT matrix for expanding the scope of ATC approach in ABC projects. The qualitative result of this study clearly indicated that integration of ATC for procurement of ABC promotes innovation, improvement in safety, reduction in construction impact, elimination of risk, cost savings, and construction time reduction. On the other hand, the SWOT matrix and decision-making framework can be used by ABC stakeholders to develop strategic planning and decide whether to integrate ATC for contract delivery of ABC project. We would like to acknowledge the support provided by the research advisory panel of this research, including Romeo Garcia, who is a retired bridge construction engineer from Federal Highway Administration, and Ahmed Abu Hawas from NCHRP Transportation Research Board. We'd also like to thank all the interviewees from Idaho, Connecticut, and Minnesota DOT who took time to share their experience and information about ABC projects that they were involved in. And again, I would like to thank ABC UTC and Dr. Mohamed ElZomor for providing an opportunity to work on this unique research project. To learn more about the methodology and results of this study, please feel free to scroll through our ABC UTC report or scholarly paper on Journal of Legal Affairs and Dispute Resolution, as well as ACE Construction Research Congress proceedings. Thank you for listening. I'm happy to answer any question that you might have.
Thank you, Mohamed and Piyush, for sharing your ABC UTC research work at Florida International University. Paul and Jugesh will now moderate the Q&A session. Paul?
Okay, Mary Lou. Thank you, Piyush, Mohamed. Real interesting, and we do have a few questions we want to ask, and we've had a question that has come in also during your talk. Let's see, and maybe we can have some discussion on it. The first one I have here is a question that says, what does an ATC, that's alternative technical concept, what does the submittal content generally include? And then does it include only design modifications, or is there a requirement to submit any other documents?
Thank you for the question. That is a great question. An ATC submittal content generally includes some form of narrative explanation of the proposed ATC. Additionally, it is also required to submit drawings or sketches of the ATC and how it is related to the current project designs. During our interviews, we also learned that the majority of the solicitation also asks the contractor to detail the impact of the proposed ATC on the project schedule, right-of-way, or permits. And some agencies also ask the contractors to submit cost data to prove that the given ATC will accrue actual savings, or to prove that the ATC fulfills the minimum cost saving constraints. While others have indicated that they want cost data to be excluded to provide a purely technical appraisal of the ATC process.
Okay. Here's another one we have is project delivery methods like design build are known to promote innovation and cost reduction in ABC projects. Why do you think it's important to integrate ATCs in such a project delivery method to achieve innovation and economic output?
That is a great question. I think there is a big difference between innovative ideas integrated through ATC and without the use of ATC. In particular, in design build project delivery method, the design builder can definitely share their ideas with the owner or integrate them after they are selected. But under the design build approach, the owner would only get benefit of one design builder's innovative idea instead of getting and comparing innovative ideas from multiple proposers. Additionally, design builders are motivated to propose confidential ATCs, which add value to the project owner, such that the ATCs can give them a competitive advantage over other proposers. So the competition among the proposers would further help drive down the costs of the project and integration of more innovative ideas. So I think that's why it is important to integrate ATC.
Okay. If any state is planning to adopt ATCs for contract delivery of an ABC project, what are some of the important lessons or procedures that you have learned from case studies that could be useful for interested agencies?
Right. I think based on our research findings, procedures for submitting ATCs will definitely vary between agencies and between project delivery methods. So one of the important lessons or procedure that state DOT can implement is to develop DOT policy documents in such a way that it ensures competing contractors are not discouraged from pursuing ATC in ABC projects. Additionally, the precise content of responsive ATC submittal should also be specified so that the contractors can estimate the resource requirements and effort necessary to prepare a responsive ATC. Other than that, any errors, omissions, and ambiguities found in the solicitation document should be addressed to ensure that the issues found in the baseline design do not become the competitive edge for the party that is able to first identify that those kind of errors, omissions, and ambiguities. And lastly, when an agency decides to implement ATC, the agency should also verify the procurement schedule and maybe allocate sufficient time for the development of ATCs and their subsequent review by the agency.
Okay, I'm just going to just digress here for a minute. In the three examples that you looked at, did those states have a formal process for doing ATCs?
Right. They have a very formal process.
They did? Okay. And
Yeah.
it's spelled out in the contract documents then?
Right.
Okay. And did any of those states, you mentioned paying for an ATC to encourage, did any of those states do that? You know?
Yeah, I mean, some of these states encourage contractors to utilize ATC from other contractors whose ATCs were not selected. So they paid typically around $12,000, like I mentioned in the presentation, to like use those ATCs in the whole construction project of ABC.
Okay. But did they ever pay money to for a contractor for submitting the ATC? Is that what they did? Like they gave him $2,000?
For submitting ATC, I believe there is no fee.
No fee.
I think let me correct that. I think there is a fee for ATC reviewers, I think.
Okay.
I'll confirm that and let you know.
Okay. I was just curious, and you were looking at what the states, if they adopt ATCs. All right, let's go on to another question. How many members does an ATC reviewer team generally have, and who are these members?
That is a great question. Based on research findings, the number of members in an ATC reviewer team varies based on the scale of the ABC project and the type of alternative technical concepts that is being submitted. In general, members who are technically qualified to determine the viability of the proposed concepts and also who can evaluate the impact of ATC on environmental impacts or right-of-way and third parties are required. It is also advantageous to include a member who can assess the legal requirements to properly incorporate ATC into construction contract. So based on our finding, we recommend including a technical expert, project management team, managers, FSWA professionals, and others as needed for unique concepts that is being submitted.
Okay. Then the next question I have here are there limitations to what we can submit as an ATC, or what a contractor can submit as an ATC? And what are some of the lessons learned from the case studies related to ATC limitations that would be useful for contractors?
Right. There were a few lessons that we learned from the case studies. There are definitely some limitations to what we can submit as an ATC. First, the Department of Transportation may outline certain items or elements that will not be accepted as ATCs in the request or proposal or invitation for bid. And these are non-negotiable during procurement. Proposals also need to submit each concept as a separate ATC. What this means is that a concept may include multiple interrelated parts, but an ATC with multiple unrelated parts could be rejected. Let me give an example. In one of the case studies of ABC project that integrated ATC, bridge slide and reduction in bridge length were allowed as ATC with conditions. On the other hand, the use of spread footings instead of deep foundation, lightweight concrete, and integral abutments, among others, were rejected during one-on-one meetings. So it is, I believe it is essential to look out for such limitations that the Department of Transportation may set for submitting an ATC.
Okay. Got here a question that came in during your talk. We just have a few questions here, but I'll go ahead and get the first one. Did the contractor participate in the huge savings the owner enjoyed in the Hastings project? If so, how were they awarded a percentage of the savings? And then if so, how were they awarded a percentage of the savings? It was a huge savings that they had on that project.
Right. Right. They had a huge savings. I believe they integrated around 8 ATCs, like geosynthetic, reinforced soil, and integrated bridge system. And I think the major savings was achieved through use of SPMT technology.
Okay, but did the contractor participate in any of that savings? And if so, how was it divided up? I think he just submitted a bid, didn't he? And then
yeah, he just submitted a bid and proposed these ATCs in a confidential one-on-one meetings, and the savings will be included in terms of the overall construction of the ABC bridge, and not the savings for the contractor, I believe.
His bid, and if he put that into his savings into the bid. Okay, that's interesting. Okay, that came from a contractor, I think, or a consultant. So it's very, very interesting. One that will do work. There was another one here that came in, and then after that, the questions are coming from during the question and answers. And this one, it says, how do you see ATC working best within a design bid build framework?
In a design bid build, I think in a design bid build, there is kind of no collaboration between designer or architect and general contractor. So like by integrating ATC, we are encouraging early contractor involvement. So that kind of helps to maximize constructability and reduction of cost, as well as acceleration of the schedules. There might be some issues in terms of legal and contractual issues when integrating ATC in design bid build, and that's what we observed in the case study projects that we studied.
Okay. We still have a lot of time. Y'all need to send some questions in if you got them. I'm going to turn it over to Jugash now. And then we have, I know, one more question, and Jugash will take it from here. Jugash?
Yeah, thank you, Paul. So one additional question came in while the webinar was being conducted. The question is, do you see the need to include material specification acceptance with design proposals if the ATC introduces a material or procedure new to a state DOT?
Yes, I believe if the design modifications includes changes in material use as well, then providing specifications for the materials will be required because it kind of is part of explaining how this material change in material will help to improve the overall design and how it is equal or better than the original material that has been used in the project.
Okay, thank you. That's all the questions that I have on my list, so I'll turn it back to Mary Lou. Thank you so much for your answers.
All right, thank you. Thanks again to Mohamed and Piyush for your interesting, informative presentation and for your thoughtful responses during the Q&A session. Thanks also to Paul and Jagesh for moderating the Q&A session, to Ollie for managing the web room, and to all of you for your participation, interest, and questions. Our next quarterly research seminar is scheduled for Friday, January the 27th. Details will be posted on the ABC UTC website as developed. This concludes today's seminar. Thank you.